Hi, everyone. Let's talk about trigonometry. Trigonometry has many functions, including sine, or cosine, or tangent, or cotangent, and there are a lot more, which you'll be learning in calculus. When we talk about trigonometry, we talk about right triangle, which means in any triangle, we are talking about one of the angle is 90 degrees. Then the other two angles, let's name it alpha or beta. And then alpha plus beta should be equal to 90 degrees. Because in any random right triangle, let's call them alpha, beta, or gamma. And then alpha plus beta plus gamma will always be equal to 180 degrees. We have another triangle. Let's name them alpha and the beta and the gamma again. Then the three angles, when we add them together, it should be equal to 180 degrees. Now, another example is right triangle. So this is 90 degrees. And the other two angles, let's call it alpha and the beta. This one, let's call it gamma. So alpha plus beta plus gamma should be equal to 180 degrees. Now, because of this angle gamma equal to 90 degrees, which means alpha plus beta, which are the two angles here, we add them together, they should be equal to 90 degrees. So the total will be equal to 180. Okay, come back to here in this right triangle. So 90 degrees here, then those two angles added together must be equal to 90 degrees. In other words, alpha should be equal to 90 degrees minus beta, or beta should be equal to 90 degrees minus alpha. Now let's focus on right triangle. So again, this is going to be equal to 90 degrees. And we will focus on one of the angle. Let's choose this one. Okay, horizontal one called the theta. Or if you want, you can choose the other one on the top, that's fine. But those two angles, add them together, should be equal to 90 degrees. In right triangle, we have two sides. So this is called a side. This one is also called a side. And the longest one, we call it hypotenuse. And once we define the angle of this one, theta, then the side that is next to it, we call it adjacent side. The side that is opposite to the angle, we call it opposite side. Let's look at another example of the right triangle. And now let's assume that this is angle theta. Okay, so those are the two sides, and this is called hypotenuse. The longest one is always called the hypotenuse. And the side that's next to the right triangle, we call it a side. So now, once we define the angle here, then the side next to it, we call it adjacent side. And the side that's opposite to it, we call it opposite side. And again, the longest one, we call it hypotenuse. Let's try another example. What if right now I have a right triangle look like this? Okay, this is 90 degrees, and those two angles added together should be equal to 90 degrees. The sides next to the right triangle is called the side, and this one longest is called the hypotenuse. Now let's define the angle here. Let's call it the theta. And you, of course, can call it another name. And the side that's next to this angle, we call it adjacent side. And the side that is opposite to it, we call it opposite side. Okay, there are other examples that we can give with the right triangle based on different orientation. But now with those three examples, 1 and 2 and 3, I hope it helps you understand in a right triangle, how do we define the sides which is next to the right triangle, and the hypotenuse, which is the longest one. Once the angle that we're interested in is defined, then we can determine which one is adjacent side and which one is the opposite side. Opposite, which means opposite to the angle. Now let's come back to here in this case. We have a right triangle. Apparently, this is 90 degrees. In trigonometry, the way how we define the sine theta, one of the function in trigonometry, it is defined by the opposite side divided by hypotenuse. Okay, so now with the theta being defined, the opposite side apparently will be y here. That's why it's equal to y just divided by r. So if you look at the definition from the left, it says sine theta equal to opposite side divided by hypotenuse. Or it is equal to y divided by r. Now let's take a look at the cosine theta. That is another trig function, cosine theta, cos. It is defined by adjacent side divided by hypotenuse. Okay, look at the right triangle here. So the angle theta is here, and adjacent side, apparently, it is the value x. So it is x divided by r, hypotenuse. Okay, how do we know it's x or y or r? In general, if it's horizontal, we call it x. Vertical, we call it y. So just like a coordinate system, we have a 0, which is the center, and here horizontal is x and vertical is y. Next one, tangent theta. So tangent theta, by definition, it's defined by opposite side divided by adjacent side. From previous discussion, we know that the opposite side of the angle is y, and the adjacent side of the angle is x. So that's why tangent theta equal to y divided by x. This is how we define three basic trigonometry functions. Like I mentioned earlier, there are a lot more trigonometry functions, but those are a little bit more complicated, and you will learn them from the calculus. Now let's talk about the components of a vector. Okay, remember how we draw a vector. Look at the example here. We have a vector r right now. We start from here and all the way going up to this direction. This is north of east at a certain degree. A particular vector always have a tail and a head. Head is where the arrow is, which means the direction it goes. And the tail is the starting point. And again, this is the direction of this particular vector r, and this is the magnitude of how large it is. With any vectors, we can always build a right triangle and find out its x component and y component. Let's see a few examples. Okay, let's have 3 examples of different vector. So in first case, we have a vector here with north of east. Let's assume that this is the starting point at the tail. So the going to the right, which means east, and then going up, which means north. So it's a theta degree north of east. Second example, again, it's a tail here, starting point, and we have an angle theta. And going to the left, which means the west, and then going up, which means the north. So it's theta degree north of west. Third example, we have a starting point 0, going to left, which means it's west, then going down, which means the source. So it's a theta degree south of west. Let's try to find out the components of a vector, which means we are looking for the x component, y component for all 3 different cases. So the key point is find the coordinate system. So the coordinating system always starts at the tail. So you can build it a horizontal line and a vertical line. So this is the coordinate system. And then now looking for the head. And you draw a vertical line towards to the x-axis. And this vertical one will be y. Okay, draw a vertical line towards to the x-axis. And this is the right triangle. And then now look at this big right triangle. This is exactly what we just discussed earlier. Okay, so the x component will be the horizontal part, and the y component will be the vertical part. And the longest one, which is the vector we're talking about, is called r. Earlier, we talked about sine angle equal to opposite side, which is y, and the hypotenuse, which is r. If we multiply r, both sides at the same time, we find that y would be equal to r multiply sine theta. So in a case, if we know the value of r and we know the value of theta, we can use a calculator to find out the value of sine theta. And then of course you can find out the value of y. What about cosine theta? The second trigonometry function here. So cosine theta, based on the definition, is equal to adjacent side. So adjacent side here is the value x, and the hypotenuse is r. And again, if we multiply r both sides at the same time, we find out x would be equal to r multiply cosine theta. Again, if you know the value of theta, you can use your calculator, figure out what is the number for cosine theta. And if you know r, then you can easily find out the value of x. In this vector r, at a certain direction, we are able to figure out the x component, which is this value here, and the y component, which is this value here. So we have the x, we have the y, and we have r, and we also know the direction. So all four variables, we know the value. Now let's take a look at the second case. The similar thing, we start off with the original point 0 and we build a coordinate system. So horizontal line, that's going to be x, and the vertical line, that's going to be y. Okay, and that is started from the tail, always start from the tail. And from the head, we draw a vertical line towards the x-axis. X-axis is below it, so we draw a vertical line down. And then this vertical component is y, horizontal component is x. And look at this right triangle here, we just built. And this is going to help us solve the problem. Okay, now, in this right triangle, we know the hypotenuse r, and we know the angle theta, which is the direction. We should be able to find out the value of x and y. So again, sine theta, based on the definition, will be equal to opposite side, which is the value of y, and divided by hypotenuse. So we multiply r both sides at the same time, we figure out y would be equal to r multiply sine theta. And cosine theta, similar way. Based on the definition, cosine theta is adjacent side divided by hypotenuse. So adjacent side in this case is value x and divided by r, and we find out x would be equal to r multiply cosine theta. Let's move on to the third case. So third case, this vector is at a different direction, south of west. Again, we start with the tail of the vector, and then find the head of the vector here. And we build a coordinating system, horizontal, that is x, and vertical, that will be y. Now we draw a vertical line starting from the head towards to the x-axis. X-axis right now is above the head point. So we need to draw a vertical line going up and connect with the horizontal line, which is the x coordinate. Now we build another right triangle. And here, again, this is the angle theta, which means that this side will be the adjacent side, and we call it x component. And this vertical component, we call it y. And of course, this is a vector that we are working with. We call it r, which is the magnitude of it, and we have the angle. South of west, which means, first of all, going to west, which is going to left from the tail. And south, which means going downward. Okay, so now we can also figure out sine theta based on the definition is equal to opposite side divided by hypotenuse. So opposite side is y, and divided by hypotenuse r. Multiply r both sides at the same time, we figure out y equal to r multiply sine theta. Cosine theta, based on the definition, is equal to adjacent side divided by hypotenuse. Adjacent side of the angle is x, and the hypotenuse is always r. So multiply r both sides at the same time, we find out x equal to r multiply cosine theta. Now, if you take a look, you find that the y component of all three cases, they actually has the same expression. They are all r multiplied sine theta, r multiplied sine theta, r multiplied sine theta. Similar thing with x. If you compare all three different cases, its expression is always r multiplying cosine theta and r multiply cosine theta, r multiply cosine theta. So here is the pattern. In order to use the same format, you need to make sure that, first of all, find where your vector is, r. And then when you build the right triangle, always start from the tail. And you build a coordinate system from there. Horizontal line is always called x axis, and the vertical is always y axis. We're looking for the angle that is connected from the origin, angle theta. Okay, now you draw a vertical line from the head. This is the right triangle that you just built. And any vectors, you can always build a right triangle, just like the example we just had with number 1, number 2, or number 3. They all have different vectors at a different direction, but somehow we were able to build a right triangle from there based on the theory or the principle we are using. This is just a general situation. With this right triangle, the horizontal component is x component, and the vertical component is called a y component. And if you are able to build this right triangle from the tail and use the angle that is connected to the tail, that is very important. Remember, we have two angles here in the right triangle. This is theta, let's call this one beta, okay. If you use the beta, which is a different angle, then the result of the expression will be changing, will be different. So that's why we're talking about the key components. Build the right triangle from the tail and use the angle that is connected to the tail. And when you build a right triangle, the y component will be always equal to r multiply cosine theta. And the x component will be always equal to r multiply sine theta. I hope this is helpful. Next time, we're going to put some numbers into it. Hopefully, it will help you have a better understanding. That's it for now. Have a nice day.